hyperbola. Okay. So asymptotes of a hyperbola are just y equals plus or minus 2 on 3, x minus 3. Yep, so the y-intercept would be plus minus 2 for both of them. Or like you can graph it and stuff, but either way the answers because like x equals 0, x equals 0, so y-intercept is plus minus 2, and then when y equals 0, the plus minus 2 doesn't be. Ellipse, just cas, and then you can go into conics and convert this to what do you call it? Like into a ellipse like equation. It gives you plus 2 y plus 2 squared equals 1, I think, if I'm reading my handwriting right. But yeah, and then if you could just divide and you get e. Or actually there's like the graphing conics, and then when you graph it, if you put the 2 points, it'll tell you how long, like in the horizontal one. Yep. And features of the graph. This is one of the questions I got wrong because it says my internet's unstable. Can you guys? I drew it and it kind of looked like this. So I put D originally because I just equated this to 0 and I got asymptotes at these 2 points. No. Sorry, I got B because I put this equals 0 and I got asymptotes here and here. But if I had graphed it, I would have seen the graph actually looks like this. So there can't be asymptotes at 2 x equals equations because there's only like one. That was x equals -2. And so the other point, x equals 3, that would have had to be a point of discontinuity because the graph shows it was not an asymptote because there wasn't like a line there. So now that's why the answer is D. Oh, sorry. You can just put it inside the normal domain, so -1 to 1, and then solve for x, and then you get x1, equals, and then it's just C. Question 5, complex number z has mod this and z2, so when you have like c equals 2 root 2, 3 pi on 4, if you have it in polar form, you can just square both things and the argument is multiplied by 2. So this is 8 cis 3 pi on 2. That's just like this here. So it's -1. So it's -8i. So given that I to the power n equals p and I squared equals -1, what does this equal? So that can be rewritten using the exponential laws like that. And then you can rewrite it again like this. And this term we know simplifies to -i using this, but like technically we already know that. Oops, I. And it tells you that in is p, so p squared times -i, and that's d. Question 7. So this is kind of a trick question. You're not actually supposed to solve for the roots. So what you're supposed to do is you're supposed to see that the coefficients of each z term are real, coefficients are real. So that means that since it's z to the power 3, there's 3 roots, and then since the coefficients are real, 2 of them will be conjugates, and when you add the conjugates, the complex part will cancel out. So you're left with a real solution, and the addition of these is also a real solution. So the answer should also be a real solution. So the only real solution is E. You can put it into your CAS, but you get like really complicated giant answers, and it takes some time. So it's just easier if you see the coefficients are real and there's only 3 roots. Yeah. So principal argument of this, is just simplify it, or you can put into your CAS, just anything, and you get C. Circle intersected twice by the line given. So first you have to figure out what the circle looks like. So this is z minus 3 plus 2i. So it's here, and it has a radius of 2. So it's like, that's like this. So I'll just label the points so it's easier to see. 1, 2, this is 3, 5, 3, 0. So this is kind of process of elimination. So you just have to check all the answers. These two are the easiest to check first. So imaginary equals 0. So that's this, the axis, the x-axis. That's a tangent, so it doesn't intersect it twice. So it's not D. E is saying reals at 5, so it's here. That's also a tangent, so it's not E because it doesn't intersect it twice. A, so if we test A, we have to like simplify it so we can draw it on the graph. So that would be x squared plus y minus 1 squared equals x plus 1 squared plus y squared. I simplified it on my page, so I'll just write what I got, equals y negative x. So that would be this graph here. And you can see it doesn't intersect it at all, so it's not that one. And then B is x minus 3 squared plus y minus 2 squared equals x minus 5 squared plus y squared. This is the answer, but I'll just expand it so we can see, 6x plus 9 plus y squared minus 4y plus 4. So these cancel. So negative 6x minus 4y. So 4x minus 4y, then x, or y equals x minus 3, and so that would be like minus 3, kind of goes up like this. I drew it as a graph on my CAS just so I could see, but you could also just draw a diagram on your page if you can draw it accurately. But yeah, that's how you would check all the answers, and it's big. So this is the rates question. So it helps to draw a diagram for this just so you know what's happening. So initially there's 1500 liters, and Q is 100 kilograms initially, and then tells you that 2 kilograms per liter is going in, so that's dq dv, 2 kg per liter, and that's at a rate of 8 liters per minute, so that's dv dt, it's 8 liters per minute, and then from here we can get dq dt by multiplying the two, so 16 kilograms per minute. dq dv here is q on volume, so volume is going in at 8 liters, but it's coming out, so dv dt is 10 liters per minute. So volume is now the initial volume, but it's losing 2 liters a minute, so it's minus 2t. So from these two, we can get dq dt is 10. To simplify that to 5q 750 minus t. So we have our two. Oh, sorry. Oh, where did it go? Our two dq dt's. So the total dq dt is dt out. So it's just 16 minus 5q 750 minus t. And that's let's say 11. You just put it into your CAS. So this is y0 equals that one, and this x, and sequence and series. You could even do this by hand just because it's only one step, but after you do that, the answer is C. Yep, nope, wrong page, sorry. The answer is D. My one, yep, okay. The answer is D. Question 12. So this is the integration trick question. So dy dx is 2x plus 1. So if we want y, then we have to integrate both sides by well, it's just normal integration in this case. 2x plus 1 dx. So we want the value of y when x is 4. So 4 to 1 because we have 1. And we want a y value. And when x is 1, y is 5. So that would be y at a y value plus minus. Okay, that's a bad way of writing it. Just technically these are x values, so I'll just write x equals 4, x equals 1. But that because we don't know the y value, even though technically we do. So it'd be y when x is 4. Oh gosh. So y when x is 4. I mean x is 1. And we know at 4 to 1, so that's just stays as 4 to 1 dx, and we know this is 5, so just add 5 to the end of this. We can take out this term, and as long as you know this part will be at the end, all of them are wrong except for C. The only one that could have been correct was A, but it had the plus 5 in the integral, so that's wrong anyway. So yeah, use a substitution. So square root x plus 1 is u. Du dx. Oh, sorry. Oh, yeah. So yeah, du dx is 1 on 2 square root x plus 1. So then dx is 2x plus 1 du. So since we have this term, we have to find it in terms of x, so we can rearrange it. So x plus 1 equals u squared, and then x equals u squared minus 1. So we have these two things, but we also have to convert the boundaries. So 2 is now, using this equation, square root 3, and 0 is, oops, error, 0 is 1. So already from that, we can kind of get rid of a lot of things. So it's not B, C, or D. So the next step, you can kind of, I guess, ignore the boundaries, but I like to leave them in case there's like a hidden something. So you replace, or you can just, so we replace this term with u squared minus 1 plus 2, because we got x as this, then this is u now. And technically this is still u, so this is equal to 2u du. So times 2u du, because we replaced the dx. So then the u's cancel, and it's just 2 root 3 to 1. Hello? Sorry. U squared plus is d. So this is a slope field. Again, first thing we check for is if there's a constant line of slopes anywhere. In this case, there isn't because it changes. To test if there's a constant line, you just draw a vertical line and check if any of the gradients are this, like if all of the gradients are the same along that line, and then you draw a vertical one and check if any of the gradients, or if all of the gradients along that line are the same. If they're not, then the differential equation has to be in terms of both x and y. Doesn't really help here again because all of the answers are in terms of x and y, so we can't really cross anything out. The next thing we look for is when dy dx equals 0 and when dy dx is undefined. So equals 0, we can't really see anywhere that it equals 0. There's some flat lines here, but I mean, they're not flat, but they're getting close to flat, but they're not actually flat. So you can kind of see that dy dx might never equal 0, and that's kind of a hint in this question, because that means it can't be D or B, because only like they can equal 0, x equals y, these two will be equal to 0. So if you look along the line of y equals x, which is this one, the gradients are not flat, so you know those are wrong. That makes sense because these are fractions. So like 1 on this, 1 will never be 0. So we check this part. The next part to check is whether it's undefined. So according to this equation, there should be a line of vertical lines at y equals x. Same with this one, but this one says there should be y equals x at, I mean, like a line of vertical lines at y equals negative x. So since these two are the same, we can kind of check the odd one out first. So y equals negative x is this line, along that line. They are kind of the same, except for the negative. So to check for the negative, we check in each quadrant. I like to check in x is negative this quadrant because like they're different, but it doesn't really matter which quadrant you choose. So if x is negative and y is positive, then this the denominator will also be a negative value. But that does not make sense because all the gradients in this quadrant are positive because they're all like going up. So that means A is wrong, and then just by process of elimination, C is the answer. You can also check C in the same quadrant. So y is positive and x is negative. So if you take a negative away from a negative, it becomes a positive. So the denominator is a positive, which makes sense because as we saw, the whole thing will be positive. So this one, you can just use cos theta equals a dot b a mod times mod B. If you solve for theta, it gives you like a weird, like, I don't remember if it was this, but it looks something like this. It looks really like a bit complicated, but if you just multiply this by 2, the whole thing by 2, and then put it into cos again, and you say it. It looks a bit complicated, but it's not that bad in your case. Question 16. So it's asking to find m and n. And so if it's asking for 2 things, we know we have to have 2 equations, and we know we have to use simultaneous equations. So the 2 things we know is that it's perpendicular and a mod is 10. So if you start with a mod is 10, 16 plus m squared plus 9 is 10. You could I just put it into my CAS, but you get a is 5√3. So it's not C, D, or E. I mean, it was actually plus minus, but like this rule is how I cancelled out the negative. And n is also given as plus minus root 3 on 3. But again, it's positive, so that's why it's a. There's actually no negative options for n, so it doesn't really matter. But for m, it's important that you make sure to read this part. So acceleration of the vector particle starts from rest is given by this, and then the velocity vector of vt is given by these equations. So velocity is integration of this. So if you integrate it, vt is integration of at dt. So you get 2 cos 2t I plus 10 sine t j plus 10e negative 2tk. Yeah, but that's not the answer because there's plus c. And then you have to sub in the starts from rest, so you have to let vt or v0 equals 0. So 0 is 2i plus this whole thing goes to 0, and this whole thing goes to 10, so 10k. So c is negative 2i minus 10k, and then you put that back in here, so vt is 2 cos 2t minus 2i plus 10 sine 2tj plus 10e negative 2 minus 10 minus 10k, and that's D. So I guess the trick with this question is not to choose B because you forget that C is an option. So question 18 is just force, vector resolution. So if one is 1 Newton, this is 2, this is 4, this is 5. So from this, so if this angle is 150 and this is 90, then this angle is 60. So if these 2 are both 60, then you can split this down the middle, and you know that each of these is 30. And then using that knowledge, you can resolute this, and it's 1 Newton up, and it's root 3 newtons to the right. Same with this one, except probably use either angle works, I guess. And you get 2 newtons down. I think, or it might not be. I don't know. I put this in my CAS, but you get 2 root 3 newtons to the left, and basically, I'll just test it actually. If you want to do it by hand, you can just do 4n sine 30 sine 30, yeah, so it is 2 newtons down. So 1 up, 2 down. So motion of the body is such that it is in equilibrium. I think I'll just, okay, so let me just highlight what's going in which direction. So this is going up. This is also going up. This is going down. And this is going to the left, and this is going to the right, and this is going to the right. So if we look horizontally, you can already tell it's not in equilibrium. So it's not A, and we know it's not moving to the north because the horizontal parts don't match up, so it can't just be moving to the north. And then if you do 5 minus 3 root 3, which is the like to like vertical force equilibrium to see which is bigger, yeah, the 5 is actually bigger than 3 root 3, so you know it's not moving to the east. And then all that's left is to check moving to the left or moving to the right. I think something's wrong with my diagram because I put D, but looks like it's not D. I think my diagram is wrong. If anyone knows why. So yeah, so 2 and 2 cancel out, so the vertical forces are 0, so we know it's not going to the north, and we can also get rid of D because it can't be moving south because the vertical forces are 0, so we're left with east and west, so you just compare 5 and 3 root 3, but yeah, that makes sense because 3 root is actually bigger than 5. That's where I went wrong. So it's not moving to the west, it's moving to the east because these two are greater than 5. Question 19. So we have vectors going like this and 5, and then magnitude of the net force. So F net is just MA, and M is 5, and we don't know acceleration, but we can find it using this one. So acceleration is V dash T, which is 6 sine of 6 cos 2T minus 8 cos 2T. Like use this equation because we need a mod. So you can put that into your CAS, either way, but I used Fmax, and it gives you acceleration of around, actually, I'm not sure if it was exact, but it just gave me 4, yeah, it gave me 8 when T was like, I think T was 5, I don't remember now, but T was 5 point something, but the maximum was 8. I chose T as an element of 0 to pi on 2, and I think that doesn't give you an answer, so I had to expand it to pi. Yeah, that's pretty much it with this question. Even if you increase the period, as long as you use Fmax, you still get the same max, so that's like, yeah. So the answer is C. Oh, it's just a police question, so always helps to draw the horses straight up. System is released from rest, and it's asking for the speed of the 5 kilogram mass after 2 seconds. So like this sentence kind of like implies, I guess, that you're going to have to use a motion equation. So if we're using a motion equation, we know that u is 0. Because it tells you, and we want to find v and t, time is 2. So we need one more variable, so you can either choose s or a. S doesn't really make sense to use s because we can't really find it. So we're going to use a, and that makes sense because we have like a force diagram, which is to find a. So we just use F net equals ma for the total system. So both masses put together. You can tell that the 5G one is going to be going down. So like system is going this way. So it'll be 5G minus 3G equals 8 times A. A is just 2G on 8, so A is G on 4. So now we know A is G on 4, and it's asking for speed. So if we have U, T, and A, the equation to use is V equals U plus AT, and U is 0, so it's just G on 4 times T, which is G on 2, so it's just 4.9. Question 21. So there's a particle, it's moving by negative 4x, fixed at the origin, and it's rest at this point, and it's looking for the speed of the particle when x is 3. So this is one of those ones where you have to choose which acceleration equation you use. So far we have a o e is, you can either choose v times dv dx, it's negative 4x, or you can choose half dv squared dx is negative 4x. In this case, the initial conditions are given to you at x equals 5, and like if it's at rest, it's implied v equals 0. So it makes sense to use this one because we don't really, if you have v squared, you're gonna get something in like half integration v squared. It doesn't really matter because you would like integrate it anyway, and you just get v squared. But yeah, yeah, for this question, it doesn't really matter. I just used this one. Did I? Yeah, because otherwise it would get a bit complicated. Yeah, that's what I was saying. Okay. Sorry, I did this paper a while ago. I don't remember. Yeah, so use this one because the other one is the complicated one. And you don't want to use this one because the V is going to become a problem. Yeah. You just put it into CAS and you just sub in these two to get your full equation when you have plus C. And then x equals 3, and you find V, and V is A. The last question is just this one, and it's asking for distance. So you have a velocity times time graph, and it's asking for distance. So distance is just area under the graph, and it's asking for area under the graph for the whole of the 9 seconds. So this equation only works from like here to here. So the rest of it is kind of like it's traveling in a straight line. So you can just assume it's linear, which like it pretty much like looks like it is. So it is. Yeah. So this part would just be 2 times 9, so it's 18, and this is 9, so 27 plus this area and this area. Those areas you would do by integration, just integration like positively, positively signed area. And if you add those, you should just get E. So that is the last multiple choice. I think so. Question 5. Question 5.